Hi, welcome to my tutorial on completing the square. I want to look at a number of things in this tutorial. First of all, I want to look at how we can use completing the square to factorise an expression, to write it in a certain format as an alternative to factorising. I also want to look at how to actually use completing the square to solve quadratic equations. And I also want to look at how we can use completing the square to actually sketch a curve of the equation. So let's have a look first of all. I've got an expression up the top here, x squared plus 9x plus 18. If I was to ask you to factorise that, we could say, let's write this, it's a quadratic expression, it's going to be in two brackets, and we're going to have x and x in the brackets. We're looking for two numbers that will multiply to give 18 and also will add to give us 9. Those two numbers are going to be 6 and 3. That's how we'd factorise that expression. We could then go on and use that to be able to solve an equation here in the form of x squared plus 9x plus 18 equals 0. And we could say, well, we factorise it first of all. So we're going to end up with x plus 6, and that one would equal to 0, and also x plus 3 would be equal to 0. So our two answers are going to be x equals negative 6 and x equals negative 3. Now, we could use them to sketch a graph of the equation. For example, the graph of y equals x squared plus 9x plus 18. Once we've solved that and made y 0 like we did here, we get our two roots of our equation here for x, negative 6 and negative 3. So I know that those are the x coordinates of my graph. I could plot these here on the graph at negative 6 and negative 3. I know that the graph crosses those 2 points. I also know that the graph is a quadratic, and it's a positive quadratic, so it's a U-shaped graph called a parabola. I also know that it cuts the y-axis at 18. So I could sketch my graph. I know that it goes through negative 6, I know that it goes through 2, and I also know that my graph would carry on up here and it would cut the y-axis at 18. So I know what that graph actually looks like. But is there a better way of doing that? Because one thing I do not know about that graph is I don't know this point here, the vertex of the graph, the minimum point of that curve. And what I want to do is use completing the square to show you how we can also find that vertex of the curve. Okay, now what I'm going to do now is I'm going to look at a different expression here, this x squared plus 8x expression here. And I'm going to complete the square on it. Now, of course, I could have factorised that normally. I could have just taken the x out, and I'll get x plus 8. If I set that equal to 0, I will get x plus 8 equals 0, so I could find my x terms as x is going to equal 0, or x will equal negative 8. So if this was the graph of y equals x squared plus 8x, I would then find my x coordinates to the graph. I know that it doesn't cut the graph, it cuts the graph at 0, it hasn't got an extra value here, my plus c, so I could plot that graph just cutting the x-axis at 0 and negative 8 here. Could do that perfectly okay. However, with completing the square, I'm going to show you how I could actually find the vertex of the graph like we couldn't do on the first one here. So I'm going to start off, I'm going to split this part here, this second term. I'm going to take this bit away from here, I'm going to split it in half. So I'm going to take this over and I'm going to position this underneath here, like that. So now I've just moved this part from here underneath. So what's happened is this now has become half, which is 4. This point here, this will be 4. So now I've got x plus 4 along the top. I've got x plus 4 down the side there. And what I'm going to do is I'm going to multiply them together and find the square of this expression here. So if I go just down to here, I've got x plus 4 squared. Now that's the start of our completing the square. What I'm going to do now is to see if this expression here, when I multiply it out, gives me this expression here, to see if I've factorised it correctly. So I'm going to multiply this out. If I write this in its double bracket format and expand that, I'm going to get x squared plus 8x plus 16. Now what you should be able to see is that this expression here does not resemble this expression here, because it has this extra 16 on the end there. That's given by this part here, because I haven't got a full square. I've moved this position, I've positioned this part underneath. I've multiplied x plus 4 by x plus 4, but remember there's this little bit missing here. Now what's the size of that? Well, if this is 4, this side here must be 4, and if this is 4, this side here must be 4. 4 times 4 gives us our 16. So this expression multiplied together is going to give us x squared plus 8x plus 16, like we've shown underneath. So in order to complete the square, to write this expression in its correct format, I need to take away this section here from my x plus 4 squared. So I take away 16. So my expression now is x plus 4 squared take away 16. If I then multiply that out, I am going to get back to my original expression there. So what can we do? We can generalize this a little bit, and we can write it in its general form. So if, for example, I had this and I wrote, let's say, x squared plus bx, and I'm now going to complete the square on x squared plus bx and look at it in its general format. What I can see here is this part here, the 4 inside, is actually half of what it was originally, because I split this in half. So the first part I'm going to write is x plus, and it's not going to be b anymore, it's going to be b divided by 2, because remember, I've halved it. But then I've had to take something away. Sorry, I need to square that. I need to take something away from that. I had to take the 16 away in this example here. If you have a look at how I get the 16 is got by doing the 4 times the 4. Well, in general terms, this no longer is 8, this is b. And the 4 was half of my 8, so I need to take away half of b, or b divided by 2, squared. So in its general format, if we've got x squared plus bx, to complete the square it becomes x plus b over 2 squared, take away b over 2 squared. What I'm now going to do is I'm going to take that same expression, x squared plus 8x, I'm going to write it as an equation of a graph, y equals x squared plus 8x. I'm going to then set it equal to 0, solve the equation, and then what I'm going to do is I'm going to show you how we can find the vertex of the graph as well. So just rub this out, just give me a bit more space. Okay, so now we've got y equals x squared plus 8x. I'm going to set y equal to 0. I'm going to solve this equation here. So I've got x squared plus 8x equals 0. So in order to do this, I'm going to complete the square. We've already done this down below. So remember, it was x plus half of what the 8 was, which is 4 squared, and then take away 4 squared, which is take away 16, and now this equals to 0. If I now take the 16 over to the other side of the equation, I'm left with x plus 4 squared equals positive 16. What I'm now going to do is I'm now going to take the squared over and square root the 16. So I get x plus 4 equals root 16. So x plus 4 is going to equal plus or minus root 16, because we know that any root has a positive and a negative answer to it. So we're going to get our two solutions. So what we're going to get here is x plus 4 equals 4, or x plus 4 equals negative 4. If I then take the 4's over to the other side, my answer becomes x equals 0 and x equals negative 8. Just like we got earlier when we factorised it in the more common manner. Now, what I now can do though is I can obviously plot these points here on my graph, negative 8 and 0. I can sketch the curve at that point, but I don't know how far down this goes. So what I can now do is I can use completing the square, the method that we've used there, to show us exactly where the vertex of this curve is. In order to do that, what I'm going to do is I'm going to look at drawing the original curve of y equals x squared. So I'm going to say we write it as a function. So function x is going to equal x squared. And then I'm going to just sketch that on there. Okay, it's just a sketch of the graph of y equals x squared. Now what I'm going to do is I'm going to look at what happened when I've completed the square on my expression x squared plus 8x. Remember what we got. We got x plus 4 squared minus 16. Now let's see what that's going to do to this. If we think about our transformations, basic transformations of curves, and we have a look at this one here. This first transformation in the brackets here, if you've got it in the brackets, it means it's a horizontal transformation and it's a translation, but it always does the opposite to what we'd expect. So what this is actually doing is it's shifting our curve 4 places, but it's shifting it to the left. So we're moving this curve 4 places to the left. So our curve's moving to there. But then we've got another transformation taking place. We have to take away 16 at the end there. Now that's outside the brackets, so that's a horizontal vertical shift, and it's going the way you'd expect it to go. So that's shifting it vertically down the page. So what's happening is this curve's moving all the way down, right the way down to negative 16. So our curve is going to be on the 4, but this point here at the bottom of the curve is going to be at negative 16. So we can see exactly where the vertex of our curve is, and we could sketch that appropriately. It's just a sketch, so what we'd do is we'd say this point here, negative 4, we're going down to negative 16, so our vertex would be negative 4, negative 16. We know it cuts here. We've got our curve, we know that it cuts at 0. We also know that it cuts at negative 8. And now we can draw a reasonably accurate sketch of that curve. What I'm going to do now is I'm going to complete the square on this equation here. I'm going to look at solving this equation by completing the square, and also how to use that to sketch the curve of the equation y equals x squared plus 6x plus 8. So first of all, let's complete the square on this expression. So if we remember the general formula here for completing the square, we take our b value here, which is 6, and halve it, and I write x plus 3, half of 6 is 3 squared. Then I'm going to take away half of 6 squared, and then add 8, and it gives me 0. If I tidy that up, I'm going to have x plus 3 squared, take away 9 plus 8, which is negative 1, equals 0. If I take the 1 to the other side, I get x plus 3 all squared equals 1. I now want to find out the square root of 1, square root both sides. So x plus 3 equals plus or minus root 1. Note the plus and minus there, because obviously a square root will have two values, positive and a negative. If I then take the 3 over, x is going to equal negative 3 minus root 1 or minus 1, and x will also equal negative 3 plus 1. So my values for x are going to be x equals negative 4 and x equals negative 2. So I've now got two of my x coordinates for my graph here. So negative 4, negative 2, I can put those on. What I now want to do is I want to be able to sketch that graph, but also find the vertex of it. I do know that it cuts it at 8. So I could just extend this a little bit up to 8 here. So I do know that this goes through there. I know that it goes through there. What I don't know is this curved bit at the bottom there, exactly where that is the vertex of that point. So what I can now do is use my initial completing the square here, this one, x plus 3 squared minus 1. And I can perform a transformation on that. So if I think my original curve, just sketch this here, my original curve of y equals x squared, I'm going to write that as a function. So I've got fx equals x squared. And then what I'm going to do is I'm going to apply the transformation here from what I got from completing the square. So I've got x plus 3 squared minus 1. So it's a double transformation there. What I've initially got to do is I've got to carry out this fx plus 3. So I'm going to shift this. That's a horizontal translation, and it does the opposite to what you'd expect. So it's going to move our original curve 3 places this way. So it takes it there to negative 3. My curve shifts to there. I've then got to take 1 away from that. That's outside the brackets. That's a vertical translation, and it's doing what you'd expect. It's moving down the axis. So this one here is now going to shift this down to negative 1. The vertex here is at negative 3, negative 1, so I can finish off my curve, and I've got my graph of y equals x squared plus 6x plus 8.